thing is first. All right, what I want to do is I want to help you with this. All right, now again, I would not expect you to know this, so I'm just going to go ahead and put it up here. All right, that's the first thing I want you to do. All right, and again, like I said, you shouldn't know this. You're not expected to know this, but it's helpful. All right. So tree diagrams are used to illustrate the total number of possible outcomes. All right. So now you're going to be able to tell me when you do experiments, what are the possible outcomes? For example, if you flip 3 coins, all right, what are the possible outcomes? All right. And then what eventually we'll be talking about is what is the probability that if you flip 3 coins, you get 2 heads and a tail? Or what's the probability that you get 3 heads? All right. So those are all things that are super easy that are actually very hard for kids to understand. All right. The tree diagrams, I used to not teach the tree diagrams to kids because I just thought it was easy. And so I didn't teach the tree diagrams, and then I would go right into probability, and the kids didn't do as well. And then I thought I was doing a good job. And then I realized that the tree diagram is what helps you understand what I'm talking about when I say the total number of possible outcomes. All right. When you flip a coin, how many outcomes are there?
2.
2. But if I flip the coin twice, how many outcomes are
4.
there? If I flip it 3 times?
6. 8.
9.
That's what we're going to talk about. It's super, super, super easy. All right. And then if I flip a coin 3 times, what's the probability of getting 2 heads? Now you're going, I'm not sure. All right. We're gonna find out. All right, we're gonna find out. But again, the most important part here is that you have at the top, your tree diagrams are used to illustrate total number of possible outcomes. And again, a tree diagram is a graphical way to show all the possible outcomes in a situation or experiment. And then the sample space. All right, a sample space is the physical listing of all possible outcomes. All right, so when I say what's the sample space of flipping 2 coins, you're going to say it could be heads, heads, it could be heads, tail, it could be tail, head, or it could be head, head. Those are the things. All right, those are the outcomes. That is called the sample space, and that is what we're going to be doing down here. All right, so again, does anybody have any questions with that? All right, again, that's just something that you have to know, you have to understand in order for me to continue. All right, and that's just basic information. All right, so now what I want to do is I want to get started with flipping a coin. All right, so here we go. For flipping a coin. All right, so the first time, all right, you get heads and you get heads, and so we call that outcome what? HH. All right. Now underneath that, you can get possible to get a what?
Tails.
Wait a minute. We're going to do it organized. Heads and then a what? Tails. All right. Now what you're supposed to see is the first number or the first outcome stays the same. Listen to me. The first outcome stays the same, and then all of the other outcomes are listed next. All right, now I'll show you that in the tree diagram. All right, then we've exhausted all possibilities with heads being flipped first. Now the possibility is what? Tails. All right, so now we're going to write down tails. And then you could get a what? Heads. Or it could be what? Tails. And so this, the outcome we would say HT, TH, and TT. All right? So these are the outcomes. All right, now the tree diagram. All right? Here's how we're going to discuss the tree diagram. All right. Your first possibility, and what I like to do here is this. I'm just going to, you don't have to write this down, just let me say. This is flip 1. All right, what are your possibilities? You can either get a what? You could get a what? Heads or a tail. So what you do is H goes down, and then what? Then T. All right, so that's what I want you to do for the tree diagram. Right now, this, good. This should be easier then. Flip number what?
2.
Number 2. All right? That branch breaks off now. Right? Now for flip number 2, I can get a what? Heads or tails. So H, T. Now, again, I'm trying to show you how when people can rattle numbers off in their head, they have been able to do the pattern here. All right, so that's why when I tell you, like I can list them out real quick, that's because in my head I have them in a tree diagram. All right, and hopefully you'll understand what I'm saying in a few minutes. All right, now if the first time you flip a head, the second time you could either get a what? Head or a tail. Now you could also flip and get a what? Tail. So now we're going to flip it a second time, and on your second time, here's how your possibilities are. You could get either a what? Heads or a tail. All right. Now again, I know this seems quite trivial, and you're probably like, well, that's so obvious to me, blah, blah, blah. I promise you as we go down the page, it's going to get what? It's going to get harder, but you've got to be able to do the simple things first. You got to be able to do the simple things. You may have any questions yet? What? Oh, I don't have any idea. Those are like branches or something. It's a good question. It's not really that big a deal. All right. Yeah. What? Okay, so let me show you real quick. I understand what you're saying, so listen to me carefully. So this right here, you flip a coin the first time. You hear me? You can either get a what? You heads or a tail. All right, so you can get a heads or a tail. Now you're going to flip it a what? You're going to flip it a second time. When you flip it a second time, that coin could also be a what? It could be a heads or a tail. So listen to me. These are the options. The problem is, right, that heads or tails could be flipped with the what? Head after you flipped a head, or after you flipped a what? Tail. So those are the options. Now, what you're supposed to do to get the total number of outcomes, because again, it could be more difficult, is you're supposed to say, now I can count these. Watch. This is outcome number what? This is outcome number, this is outcome number, and this is outcome number what? 4. So your outcome number 1, I want you to be able to tell me should be just what? HH. Number 2 should be what? HT. Number 3 should be what? TH. And number 4 would be what? TT. All right. Now that's exactly what it means. Now listen to me. I promise you. All right, it's going to get harder. But again, I had to show what? The most basic. All right. Now, what I want to do, because we're great, is we're going to go ahead and answer questions 1 and 2. So, number 1, it says, what is the probability of getting both tails? So obviously, Alden, that would be what?
25%.
Yes, we could say probability, but generally probability is not as a percent, it's as a fraction, even though,
1/4.
yeah, we would say 1/4. All right. Now, how did I know it was 1/4? Because I looked at how many possible outcomes are there, guys?
4.
There are 4 possible outcomes, and there's only one with both tails. That's how we got 1 out of 4. All right. Now, what's the probability of getting at least 1 tail? So if I want to get at least 1, that means it could be either what?
1 or 2.
1 or 2. 1 or 2. So Tell me, what's the probability of getting at least one tail? What would the probability be? Lily. So first of all, how many outcomes are there? 4, so that goes in the denominator. Now, look at our outcomes. Look at the green. How many of them have at least one tail? How many? 3 of them. That's your answer. 3 out of 4. Right? Because at least one. Does the first one have at least one?
No.
No, it does not. But yes, yes, and yes. Is everybody okay with that? All right. Now, I'm trying to find something here. All right, so here's what I want to do. All right, I want at the bottom of the page, we're going to try to draw a tree diagram where we flip what? 3 coins. And I want you to draw the tree diagram for flipping 3 coins. Let's draw the tree diagram for flipping 3 coins. All right, everybody give it a shot. I want to see what you can do. See if I've made any sense. Is that done? Try to draw the tree diagram at the bottom of the page. Perfect. Try to draw the tree diagram for flipping 3 coins. And it should look very similar to what? To how many? 2. Should be similar to that. So here's flip number 1. What are my outcomes?
Heads.
Nope. Nope. Flip number 1, I can get a what?
Oh, heads or tails.
Heads or tails. So under flip number 1, we just write H, and then we write what? T. All right. Now let's try not to make it so big because it's not necessary to make it so big. All right. Now, here is, let's see how you're doing. Here is flip number 2. For flip number 2, I can get either a what? Still just a what? Heads or tail. But every one of these has a branch. So on that branch, I have to put what? H, T. And on this branch down here, I have to put what? H and T. All right, now come on, guys. I just don't think that's that hard. But I cannot tell you how important that is to know that. All right, now we're going to flip it a 3rd time. All right, so now watch. Flip number 3. So each one of these has its possibility of what? HT. So here we go. So here's a branch here. HT. Here's a branch here. HT. Here's a branch here. HT. Here's a branch here. What?
HT.
HT. Now, like I said, I don't think that's that hard. But now, watch me list out quickly all the possible outcomes of flipping a coin 3 times. All right? How many outcomes are there, by the way? How many outcomes?
8 outcomes.
8 outcomes. Now, how do we know there's 8 outcomes? Because, again, if we wanted to, we could just count. This is number what? 1, 2, 3, 4, 5, 6, 7. There are 8 outcomes. All right, now watch how we can just now quickly go through and tell me the possibilities. What's the matter?
Why would you count like all of them?
I don't know what you mean. Oh, because here's why. Now I'm going to show you. All right, that's a good question. I understand what you mean. So now follow me. Right? If you flip, the first coin could be a what? And then a what? Then a what? So choice number 1 would be H, H, H. So now please watch. Number 2 would be what? Uh-oh, hold on a minute. Nope, you got to stay with me.
HT? Oh,
H, H, branch. What is it?
HHT.
HHT. Here we go. HHT. Now, have I exhausted all the way to the top?
No.
Yes.
Yes, I have. HHH and HHT. All right, I can't go any higher after HH. Does everybody agree?
Yeah.
So now I'm taking the next road.
HT.
All right, go ahead. John, go ahead. HTH. That's road number 3. HTH. So, Mr. Danzig, give me number 4.
Number 4 would be H. Wait, no, would be
H.
Wait, HT.
HT.
H.
No, we
T.
already.
Oh, T. I'm sorry.
HTT. Come on, that's what I'm saying. Stay up. HTT. So everybody writes number 4. HTT. All right, Ryan, help me out, please. Now, have we exhausted everything where H is first?
Yes.
Now, all right, Ryan, start me off with the next one. Yes, good job. Just THH. And then the 6th one. You're awesome, girl. THT. THT. And then let's do Morgan. What? Good job. TTH. And then our last, yes, is directly at the bottom there. All right, which we would call TTT. All right. Now listen to me, guys. I'm trying to tell you, believe it or not, that's how people organize numbers in their head. Now you're asking me a question, well, that's not really organizing numbers. I will show you that's how you organize numbers. All right. So now, how many outcomes are there here, guys? 8. So now I want to tell you how they figured this out. All right, so I want everybody to pay attention now. This is the important lesson. It's called the fundamental counting principle. All right, the fundamental counting principle. So what does that mean? All right, how many times are we flipping a coin? 3 times. So pay attention. This represents number what? This represents number
2.
and this represents
3.
3. So this guy was trying to do all this work, and he finally figured out the pattern. How many options do we have on the first flip?
2.
2. It can either be what?
Heads
Heads or
or tails.
tails. So then he said, how many options on the second coin?
4.
No.
6.
No. How many?
2.
Still what? Still 2, because you're going to flip the coin, and you're still going to get a what?
2.
Heads or
Oh,
tails.
straight 2.
All right.
That's math.
And then the third flip is a what?
2.
Heads or tails. So this guy goes, wow, there is a relationship between the numbers and the possible outcomes. And what was the relationship, Kiara? What do we do? No. Say it. You multiply your possible outcomes for each individual flip, and that will give you your total number of outcomes. So look right here, Alden. Yeah, come on. Yeah, it's not necessary. I'm in math class. It's not dance class. That's later on. All right? Times 2 times 2. And if I multiply 2 times 2 times 2, what is that? 8. So what I'm trying to show you is this number corresponds to this right here. All right? So all you have to do instead of doing a tree diagram is to take your possible outcomes and multiply them together, and that will give you your total number of outcomes. All right? And again, that just revolutionized math once they figured out that concept. Because you think about it, like, has anybody thought about the lottery? Like when you pull those numbers, how do they know, seriously, that there's like 47 million different possible combinations? Who counted them? Is that the bell?
Yeah.
All right, so we will take up, guys, excellent day today. We will take up right where we left off today, tomorrow. No homework, except to review your test. That was awesome.